specific gravity, which is also known as the density. The density is the mass per unit volume, and its symbol is rho, which can be abbreviated as rho m over v. The units for density is grams per centimeter cube, which is convertible to kg per meter cube, or kg per dm cube, or kg per liter. So remember, while you are doing your calculations about the density, remember to indicate the units, that is either in grams or kg. Now, density is divided into absolute density, which refers to that density of substance in closely packed form. So that is the absolute density. It means there is no voids involved. While the apparent density, or the volumetric density, or the mass density, is defined as the density of a substance with respect to bulk volume. So it means here we are calculating the density with reference to the voids included in the substance. So always the bulk density, or the apparent density, or the volumetric density, or the mass density is a little bit higher than the density of the absolute density of the same substance. Relative density, or the specific gravity ratio of the substance to that of a standard substance. So for example, water, it has no units because it's a ratio. So to find the relative density, or the specific gravity of a substance, we say the density of that substance divided by the density of water. And there are three methods of determining the density of liquids. That is the use of psychrometer, relative density bottle, and this use of hydrometer. Of relative density of the specific gravity by the RD method, which RD is specifically used to determine relative density because it is specially designed to hold accurate volume of a substance. Now, the procedure of doing an experiment or determining the relative density of a liquid, that is, first of all, you have to weigh the clean and dried empty relative density bottle with the stopper on a calibrated balance and determine it as weight 1 and record your readings. Number 2, you need to fill the relative density bottle completely with the liquid you are measuring and place the stopper gently. Even if there is a spill on it, make sure that you wipe and weigh the bottle again. Now, that you will record as weight 2. Now, that procedure is you remove the liquid from the bottle and make it clean and dry and fill it with water into the bottle and repeat the same procedure. That is putting the stopper gently and wiping the excess overflow. And then you weigh and name it as M3. From the above procedure and the records you've made, now we can determine the weight of the liquid and the weight of the water. Now, the weight of the water and the actual determination procedure of the weight generally is the weight of the substance plus the RD bottle minus the weight of the RD bottle and stopper when alone. So to find the mass of the liquid, we therefore say weight 2 minus weight 1. And simultaneously, the weight of water is weight 3 minus weight 1. And finally, we conclude our procedure by calculating the relative density of the liquid. That is by the use of the weight of the liquid divided by the weight of the water. There are factors affecting the density of liquids. The first one is intermolecular attraction. Greater the intermolecular attraction, greater the density of a liquid. For example, water has a greater intermolecular attraction because of the double hydrogen bond. Number 2 is the molecular weight. In general, greater the molecular weight, more the density of a substance. For example, the density of ethanol is 0.789 because the molecular weight is 46. And that of propanol is 0.8 because the molecular weight is 60. Now, on the other hand, we have those which have lower molecular weight but has a greater density. For example, water and ethanol. Ethanol has a molecular weight of 46, while water has a molecular weight of 18. So water is an exceptional case here, whereby we say that greater the molecular weight, more the density of a substance. So take note of this. Number 3, we have the temperature. Generally, increase in temperature increases the intermolecular forces, so therefore decreasing the density of a liquid. Application of density or specific gravity in pharmacy. The first one is to calculate and determine the binary solutions. That is to determine the amount of solute that is needed to dissolve so as to achieve a specified therapeutic effect. So it is useful in determining the concentration of the binary solute and solution. Number 2, it is used in filling control volume. Remember, pharmaceutical products are dispensed in volume, but they are prepared by weight. 3, to determine the percentage weight by weight of mineral acids. This is to mean that acids that are combined, or the mineral acids that we have, are presented mainly in the form of percentage weight per weight. So taking a reduced quantity will not be an issue, whereby we have the percentage weight per weight and where the density is known, because when you know the density, it easily you are in a position to reduce the large amount of mineral acids to a smaller volume of mineral acids. Number 4 is to determine the percentage weight per volume, the molarity and normality. The formula is percentage weight per volume is equal to percentage weight per weight times specific gravity. So it is easier to interconvert between the molarity and normality using the formula which is there. So the formula for molarity, for instance, is the percentage weight per volume times 10 divided by the gram molecular mass. So this is the formula, and the formula for normality, you have the percentage weight per volume times 10 divided by gram equivalent. So this is just to elaborate the fact that density is useful in determining the percentage weight per volume, the molarity, and you can interconvert to the normality of the mineral acid. Number 5, density is useful to determine the flow properties and compressibility of powders. True density of powders is used to predict both flow properties and compressibility. That number 6, density and dispensing pharmacy in calculating the desired strength. Number 7, density is used in diagnosis of diseases. Density is used in the diagnosis of diseases such as hypertenuria, which is increased solute in urine. So degrees in specific density may be associated with renal failure, nephropathitis, diabetes insipidus, acute tubular necrosis, and intestinal nephritis. It's useful in separating these minerals. So density separation of mineral is that because of the fact that different minerals have different densities, then it is very easy to separate these minerals. Number 9, density is used to identify and check the purity of substance. Density or specific gravity is a characteristic of physical properties. So pure substance have specified density. So it means if density is used to identify and to check the purity of substance, density or specific gravity is a characteristic product, that is, pure substance have specific density. There is no intermediate. Number 10, density is applied to determine the osmotic pressure of the solution.